Hello and welcome to my YouTube channel. This is Ramani Online Mathematics. If you know you have not subscribed, please subscribe and share to your colleagues. Now we are going to look at rates. Already you have done with the ratio. It was ratio and rates. Done with the ratio, we are now looking at the rate. What is a rate? We are saying that a rate is the ratio of two different quantities. It's a ratio of what? Two different quantities. So let's say when we have a distance and we have what? An hour or time. So when you have a distance and we have time, it's a two different quantities. In fact, much focus is going to be on this. Is that okay? So now let's look at what an average speed is under the rate. Now, let's look at what an average speed is. Average speed is giving us, now the abbreviation form is S. Is that okay? It's giving us the distance, which is giving us D over the time taken, which is giving us small t. So that is the formula or the definition of what average is, the ratio of distance to what time taken. So that's the mathematical form of what average speed. Now for average speed, it can be measured in either kilometers per hour. So this I write kilometers per hour, the short form. You can also have meters per second. This is the meters per second. We can have kilometers per minute. So when you see this long line, it is called per. So kilometers per hour, kilometers per second, and kilometers per minute. Is that okay? Yes. So that's what you are going to use in all the calculations that we're going to do so far. So I have these two beautiful examples here that we are going to exercise you solve more. So let's read these examples and let's try to solve them. Okay, now let's look at these examples. A car travels 72 kilometers in an hour. Is that okay? So let's put down the data. So the distance was covered is what? 72 kilometers. Is that okay? Yes. So that's the distance was covered. Now, in an hour. So time taken to cover that distance. So time taken. So time taken is what? 1 hour. So that's an hour. That's 1 hour. It is 2 hours. It will be mentioned or to be given to you. Find its speed in meter or meters per second. So you want the speed and they are giving you the average speed. Okay. The average speed was given us what? The distance over the time taken. So this what was given, right? Now, distance has been given as 72 kilometers. Time has been given as what? An hour. But one thing you have to put in mind is where they want us to leave the unit is meters per second. So meters per second, you know what to do. For the meters per second, these are what? Kilometers and what? An hour. So you need to change this 72 kilometers to what? Meters. So you know that, look at the conversion. You know that every 1 kilometer gives us 1000 meters. Is that okay? What this means is that 72 kilometers will give us what? 72,000 meters. So that's the conversion. Now, also let's look at the time. We know that every 1 hour gives us 3,600 seconds. Is that okay? I'm converting it to seconds because we want it in seconds and it is 1 hour. So every 1 hour is 3,600 seconds. So we are going to replace the 72,000 meters here at the distance. So it means that our distance is this. This is our time. So our speed is going to be 72,000 divided by 3,600. Okay. So this zero goes with this zero goes with this. 36 can go into 720 20 times. So it means that we have speed to equals to 20. But we say we should leave the answer in what? Meters per second. That's why we converted everything in terms of meters and seconds. So meters per second. So this is the answer to this question. Thank you. Now let's move to the second question. Okay, now let's look at the second example. A train travels at a speed of 80 kilometers per hour. So the train traveled at a speed of 80 kilometers per hour. Is that okay? How long will it take to travel a distance of 320 kilometers? So what are we interested in finding? We want the time taken by the train. So let's see how we go about this. So solution. Now, a train travel at a speed of 80 kilometers per hour means that the speed has been given. So my speed is equals to 80 kilometers per hour. Is that okay? How long will it take to travel a distance of 320 kilometers? So distance is what's giving us 320 kilometers. Is that okay? So we need the time taken. So that's why we need. We know that the formula is speed equals the distance over time taken. So the speed is 80 kilometers, right? So there's no need to bring the unit, okay? When you are doing a calculation, distance is 320, right? Let's represent the time by small t. So this is over 1. So you can do cross multiplication. T times 80 is 80t equals 320. Is that right? Yes. So you divide here by what? 80. Good. You divide here by what? 80. So it tells you that 80 go into itself 1, leaving my t, which is the time, to be 0 go into itself 1. 8 going to 34, that's 32. Okay. I beg your pardon. That gives you 4 hours. Is that okay? 4 hours. So the time that is going to take is what? 4 good hours. Yes. So let's move to the next examples. Okay, now let's look at the third example. Please make sure that you pause the video and try your hands on it. Okay. If you are watching it at anywhere, you can also go to my YouTube, Dramani Online Mathematics, subscribe and share to support my work. Now, we are going to look at the third example where we said that Kwame rode a bicycle for a distance of X kilometers and walked for another half an hour at a rate of 6 kilometers per hour. So 6 kilometers per hour at that rate means that that is the speed. Is that okay? That's the speed. If Kwame covered a total distance of 10 kilometers, find the distance X he covered by bicycle. Okay, so that's what you are going to do. The first thing that we are going to look at is the distance of X kilometers. He used the bicycle to cover the distance of what? X kilometers. So let's write that one down. Distance covered by bicycle is equal to what? X kilometers. So that is it. And walked for another half an hour, and walked for another half an hour at the rate of 6 kilometers per hour. What is 6 kilometers per hour? It talks about speed. So here, um, the speed. So that's why we use what rate. They said rate, okay, is what, and that one is by foot. When he walked with 6 kilometers per hour. Is that okay? And as he was walking, the time he used, the time taken at that time was half an hour. Is that okay? So what you do here is that, okay, let's move on. If Kwame covered a total distance of 10 kilometers, the walking plus the, you know, the riding of the bicycle takes a total distance of 10 kilometers. So total distance covered by Kwame is 10 kilometers. Is that okay? Good. So all you need to do is that if I'm able to get a distance covered with his walking, then I add it to the distance covered with a bicycle. Then I just equate it to 10 kilometers. That is a very simple thing to do. So let's look for the distance covered with walking. So we know that that one has been given as speed is equals to, right, the distance over what time taken. Okay. Now for this matter, you know that the speed is given, and the speed is given as 6 kilometers per hour. So we have 6 equals distance. That's what we are looking for the walking. Is that okay? So we repeat the d, that's the distance. The time taken was half. Is that okay? So here's over 1. D times 1 is d. Half times 6 is what? 3 kilometers. So this is the distance that was taken in terms of walk. So we know that the total distance given was what? 10. What it means is that if I take the x, that's the distance covered with a bicycle, plus 3 kilometers, that's the distance covered with walking. So that is what? 3 kilometers. And this should give me what? 10 kilometers. That's the total distance. So it means that my x equals 10 kilometers minus 3 kilometers. So my x equals 7 kilometers. And this is the distance covered with what? Bicycle. And I think this is so simple. So please try to follow me and share. Thank you very much.